Derek Kominek, as Anna mentioned, and welcome to our webinar. So the things that we'll cover today, sort of divided it into, let's say, three main chunks. The first one, I think, if we're going to talk about, the comparison of OPC UA to OPC Classic, it's worth getting a feeling for what is the context that these standards are now operating in. Because as much as, the rest of the presentation talks about the actual specifics of how the standards compare to each other, I think it's also important for everyone to have a good kind of grounding of what's at stake or what is actually happening sort of around the world as we move forward with the new ways of connecting and what's expected from that. So with that context, I think we will then more easily understand why some of the things that are different between OPC UA and Classic OPC, why that really matters. So we'll go through that, then we'll talk about sort of three key areas, I think, of where there are major differences: versatility, security, and usability. And then Stan, since they do a lot of the consulting work for us as one of our eco partners, they do a lot with OPC UA, so he will cover some of the actual, what can you do next type scenarios for both, with a focus both for end users and as well for automation vendors or developers, because really there's two sides to this: those who need to implement the technology and those who need to adopt it and start using it. Okay, so let's take a look at the first part, data interoperability in the IIoT and I 4.0 world. So overall, you hear a lot of terms, and this has been going on now for probably at least 2 years, where there's been quite intense about talking about digital business transformation, Internet of Things, Industry 4.0. A lot of different terms, all referring to how many things can be connected to many other things, and there's a lot that you can do with the data that's collected, and there's a lot more sort of interaction and activity that opens up various opportunities for basically everybody within, let's say, an enterprise. So whether that, you're working on the shop floor, and it's how you set up your systems down at the lowest levels, or the IT departments, how they're trying to work with production and the business side of things, keeping those sort of together, harmonizing them. The types of businesses that you can run, the services, you probably all have heard a bit about, software as a service and equipment as a service. So basically, with the ability to better monitor systems, you can start offering the services or the products in a slightly different way. So there's a lot of excitement about what's possible as you start to connect things and remove barriers, but there's also obviously a lot of concern and sort of evaluation as far as, how practically can that be done, and is it sustainable, and is it safe to do it, quite frankly. So there's a lot of excitement about that, and that's basically, it's happening, right? There's a lot of movement that's going that way. We're going in that direction. So businesses will typically evaluate, well, what's in it for me? And, this snapshot that I'm showing here is, let's say, from the point of view of a process-focused, let's say, manufacturer or producer. So, there'll be key drivers like production efficiency, sort of high-level goals that more the decision-making level that people come out and say, okay, well, we want to improve our production and our process reliability, and we want to have a better coordination with our supply chain, lower the cost of shipping, and better coordination with the supplies, and a lot of other things. And of course, all of this hinges on, and by the way, I want this to be secure. So people generally group it under cybersecurity, make all this safe, but we'd like to aim at all of these benefits. Now, when we look at these top-level benefits, they break down to a lot of different activities that happen sort of below. There's lots of components and processes and functions that people perform that roll up into these sort of high-level goals. So how does the IIoT and therefore eventually when we get down to OPC UA, like how does that impact this? Well, if you really look at it, and regardless of whether you're doing manufacturing or production, you've really got two key levers that are going to be sort of, you can work here. One is the ability to locally basically start introducing local collaborative and autonomy, which basically means that systems rather than having to be overseen and have massive programming set up in order to coordinate the individual components. As you start putting more compute power down into the components locally, and they're better able to share information, some of those things can start to be done at the local level between the systems, and therefore you start seeing more autonomy. The other way to look at this is to look sort of in the broader scale and to say, well, you know what, actually, if we start to optimize our system basically through let's say a global orchestration, which means that now you're benchmarking and you're getting more of the information that's coming from, the various sites and various locations. So you have a better global view of what is happening, and you start to coordinate things better that way. So sort of going in both directions, becoming autonomous down, lower, below, and also at the same time having a much broader context of what's happening throughout. So, all of this, if you take it together, you really start to notice that, there's a lot more moving pieces being involved here in order to make this happen, to orchestrate this, than just the talk of, can you connect, one piece of equipment to another piece of equipment. There's many more context. So in this sort of environment where you talk about IoT, an important thing to notice is that, there will be different viewpoints, right? So we need to look at the technology and what is actually happening with IoT from, for example, in the IIC, so Industrial Internet Consortium, in their reference architecture, they break things down and say, okay, hey, if you're going to be designing systems, we need to look at it from a business viewpoint, a usage viewpoint, functional, and implementation, right? Each of those, so whether you're trying to get value out of the system or you're trying to figure out how do you actually commission a piece of equipment that you just got and how easy or difficult is that, or how you're supposed to actually use it for the applications, each of those has its own requirements, and the underlying technology has to sort of address each of these. So the requirements when we start talking about connectivity standards have really expanded, and the context has changed in which a connectivity standard operates in. At the end of the day, it still does the same thing in the sense of you need to get data from A to B, and the connectivity standard would say, well, how do you do that? But the horsepower that it has, or how robust it is to properly integrate with the different systems that are going to be also involved, because that's how the whole enterprise is set up, that's really sort of the new level that we've come to. We've kind of breached that level where it's not just, can OT and IT cooperate? It's actually mixed, right? They have to be mixed together and actually start working as one in order for all of this to work out. So this is sort of a starting point that we now say, okay, well, so given that there's a lot of requirement around this from different perspectives, it starts to narrow down the field of which standards for connectivity are actually appropriate to talk about as a foundation for your communications in your organization. And OPC UA has been evaluated and looked at by two key organizations that focus on not necessarily implementing a solution, but for describing or creating a structure to describe how solutions should look or how they should be put together overall when you're trying to implement IIoT type technology in today's world. So we have the IIC, Industrial Internet Consortium, and we also have the platform Industry 4.0, which is more of a German origin, focused on manufacturing. So it's basically a horizontal, let's say, slice out of the entire IoT sort of spectrum that you would look at. It's just focused on manufacturing, but it deals with the same technologies. So for both of these organizations, they went through and started to evaluate and identify which standards for connectivity out there would actually qualify to be considered a core standard. And OPC UA shows up basically on both radars, right? So the IIC considers it a core connectivity standard. There are others, and I'll be showing you a slide in a second that describes that. And Industry 4.0 went a bit further because their scope is a little bit more focused, they actually start to say, well, these are the standards to use, not one of the ones you could use, but basically here's the ones that you need to use in order to take full advantage of Industry 4.0 type initiatives. and OPC UA is that core. Okay, so in this environment, or say given something this broad, it turns out that we need to start to structure or to plan a lot more carefully which components are going to go into our systems, not necessarily as in the past where, vendors would have proprietary communications and you're trying to sort of pick your way through, well, what will connect to what and who has, which functionality do we need, but also will that work with our system and how hard or easy is it going to be to integrate it? Rather than looking at it that way, now it's a question of, given where we're trying to get to, these standards, which ones are going to be the long-term standards that are actually going to support what we need it to be supported. So the Industrial Internet Consortium created this, wrote up, they have a lot of actually very good documents on various facets of what, what a system looks like in IIoT. But one of the key documents that they wrote is this Industrial Internet Reference Architecture, or IIRA, which actually structures it and identifies how all the different viewpoints and the different use cases and the different sort of functional views within them, how they all coordinate together in order to create one cohesive system, an IIoT system. At the same time, Industry 4.0 came out also with a reference document, and that's the reference architecture model for Industry 4.0. So it turns out that there's actually a lot of parallels, and there's actually an additional document that's come out that actually shows the sort of harmonization between these two different specifications or reference architectures, and they actually overlap quite nicely with each other. But basically, each of them ensures that they looked at the different viewpoints, not just purely from a connectivity standpoint of how does the technology talk from A to B. It's actually how do the different organizations or groups within a company or between companies, how can they actually, make everything work together. So there's a lot to be worked out, and we can all be experts in something, but nobody can be an expert in everything. So the important part when we're making decisions about moving forward with just overall connectivity technology is to make sure that you leverage the expertise that these types of organizations provide, which starts to bring in various aspects together so that that the pieces that you're choosing actually align with the overall solution that's required. Okay, so in the end, seamless, reliable, cost-effective system interoperability is absolutely crucial for these types of systems in IIoT. All right, so given that there's this broad introduction with, how many, core standards there are and then how important the connectivity is, here's a quick snapshot. This is taken right out of actually the IIC's, the reference architecture. So here are the standards that they've identified that are important. And of course, there are different uses for different standards depending on what you're doing, whether you're doing, fully engineered sort of software systems, which would be more towards the DDS side, or you're doing more third-party ad hoc connectivity, which is typically what you see in plants and manufacturing environments, where basically you're bringing in third-party devices or systems or applications, and they all just need to start working together with each other. That's where OPC UA comes in. So when you look at OPC UA, the footprint that it covers is this. So the lower levels, the colors represent different levels which are identified, the network levels identified on the left, so physical link, network, transport, framework, and then up to applications, etc. As I'm just reading up the left side of the screen. The boxes in red identify which, for example, transports OPC UA uses. So OPC UA has, obviously, the specification identifies how you structure, the actual information, the packets or the frames, how they get put together, and how all that works, and how you implement security, etc. But then it also has to use transports, which sit below, to say, well, what's the method that we're going to use to actually deliver and to move the information around? OPC UA has a number of different methods related to that. And so whether you're doing pub-sub, where you're talking, it's one way to exchange the information, or you're doing client-server architecture, that's another way. It'll choose different pieces of this framework. But when you go to OPC UA, you've got a large swath of these core functionalities type of within the communication standards covered by OPC UA. So the criteria, some of the examples of what's required for a standard to be added into this into the IIRA the framework is things like syntactic interoperability. It has to be secure, performant, scalable, reliable, resilient, etc. You can go down the list. So there's quite a bit in there, and basically that's where OPC comes to shine. So given that background, now let's take a look at some of the key sort of differences and comparisons, I guess, between OPC UA and Classic. So the first one I thought would be good to sort of summarize is just OPC UA's versatility. So if we're going to compare Classic and OPC UA, number one, we can look at the scalability and sort of where it can run. So OPC UA is not tied down to any particular operating system or any type of platform. So whatever hardware you're going to run it on, or whatever operating system you want to put it on, that's quite irrelevant to the standard. The standard doesn't tie you down to a particular, one vendor's OS or another. So it can be very small. It runs right down in a device that, for example, has no operating system at all. It could be bare metal. Or it can run on massive web-based processors, servers that can handle thousands of clients connecting to it and pulling data from them. So whether you go from embedded to PC, it's all right. It works with OPC UA. It also allows the servers, when they're being connected on your network, to be discovered. So discoverable, but basically discoverable. But you don't have to go to each PC to search, or each piece of equipment to say, hey, ping this thing, does it have an OPC UA server on it? Those servers actually register themselves with something called GDS, Global Discovery Server, and basically it will identify, when a client goes to the GDS, it finds which servers are available. So basically you have more like a directory. And depending on your permissions, because we'll talk about security in a sec, you either will or will not see them. So there's a lot of control as far as who gets to access what. Now, if we turn back to Classic OPC, which was a fantastic, step forward 20 years ago, when we're trying to get past, proprietary communications and just finding a common way to talk. At the time, basing it on Windows and using basically the Windows sort of communication system known as COM and DCOM, that was great back then, or at least it was the option chosen at the time. There weren't that many options for it at the time. Of course, nowadays that looks quite primitive or just aged, right? So basically, if you're using OPC, if you have that infrastructure in place, that does not mean that, well, now it's time to rip it all out because it's older. It just means that as you're going forward, it might be a good thing to start looking at how to at least start a phased adoption in order to start blending in the new technology while you're still continue to get your value out of your existing technology, and maybe propping it up a little bit given some of the new utilities that are out there as well. Okay, so Classic OPC obviously just runs on Windows, and you have to find the different servers per PC, and you have to have permissions therefore to talk to them. Another difference is the type of transports that are used. So in OPC UA, it's quite flexible. When you're thinking about a communication standard, it's not I wouldn't call it a protocol, it's a standard. The difference being is that, protocol can mean many things to many people, and depending on what level in the network sort of diagram that you're looking at, the layers, you might think of different things of what the protocol means. So OPC UA uses different transport protocols depending on what environment you're operating in. If you're using, you're on your LAN and you're connecting, or you want to talk client to server, so you have point-to-point connections where you're exchanging information back and forth. The client is bidirectional. They're talking with each other, making requests from the server is writing back to the client. The typical architecture that you would be familiar with for OPC, obviously OPC UA has that in spades. It runs binary, OPC UA binary protocol over TCP. Of course, no DCOM is being used. That's purely TCP. But now we've got new interesting scenarios where when you want to talk to cloud, there are technologies that we have now that are very good at doing just that. And MQTT is a very popular one at the moment. So that transport is now also part of the pub/sub spec, which just means that you're still keeping all the other functionality that OPC UA has, whether it's the context or how security is established end-to-end, but it now can run over MQTT and run as pub/sub, which just means that the server, let's say, would take the role of typically a publisher, starts publishing data, and servers or subscribers sitting in the cloud could just pick that up if they have the right permissions over MQTT. You can also go down lower into the company to the shop floor, and let's say that you're looking for sort of machine-to-machine or controller-to-controller communications. Now, again, you can use the pub/sub mechanism, but switch out the transport and use UDP, which allows you to broadcast information on your network, and whoever needs to pick it up can, and it can happen very quickly because you're not doing a handshaking back and forth. So OPC UA provides a lot of flexibility above, below, or at the level that you're sitting in order to best facilitate how to get the data and more security from A to B. Okay. Also, when you look at connection recovery, so whether connections go down and how the whole system recovers, and whether you can request information that you may have missed when that connection went down, all those things are built into OPC UA. If we go and take a look at OPC Classic, of course, it was built sort of a, purpose-built. It's kind of like OPC UA is like the modern cell phone where you've got, you can run lots of applications, install them. You can do all sorts of things on it. OPC Classic is more like the old cell phones where basically they're single purpose. You connect, you get your time, value, quality, and you have a naming convention, and that's what it does, right? So that's exactly where this sits. It's quite sensitive to unreliable networks, so you get decom timeouts if you're using the pure classic OPC. You have to use typically other third-party tools, for example, like tunneling software, in order to try to eliminate the decom side to make it stable. And it works. It's just that you have to add additional components in to make it go, right? And it's not suitable for things like trying to go down into M2M or systems basically where you wouldn't even find Windows to begin with. Okay, moving on. A key one also now is, aside from the sort of structural or infrastructural components, there's also a question of how much context your data has. So the more you share this information, just as we saw in the the different viewpoints that you can look at systems from, or the layers across which you share the data, the more context that you preserve or are able to describe from the lowest levels moving upwards, of course, the more useful that information is, both from an analytics point of view, because you have more context, so you can better select and work with the data. And at the same time, just for the users themselves, they just get a richer experience as far as what they're working with, what units they're using, what the relationships between the things are, whether you can group them so you can talk about an entire production line as opposed to just talking about individual components and registers on those components. It's just different viewpoints by different people how it works. So OPC UA has complete information modeling, and part of the power of that is that it was designed not only to be, let's say, interoperable for components trying to communicate, but as a standard, it can collaborate or work with other standards. So basically companies are creating, or the vendors are coming together, interest groups come together, and they can create what are called companion specifications, which are basically information models written in OPC UA to describe various components and systems from different industries. And once they create this companion spec, it's something that an OPC server can read in. So everybody in that industry can then use that one companion specification, which is publicly available, in order so that everybody describes a valve, or they describe an actuator, or whatever the piece of equipment is, as long as, let's say, it can be standardized, or a standard already exists in that specialized field. That standard can now be translated into OPC UA information modeling, and regular OPC UA servers can read that information model in, and they can work with it. So that means that not only does OPC UA facilitate, let's say, secure connectivity or moving data around your network, but the type of data and how it expresses it is very flexible as well. And that's where information modeling comes in. And it's really something that will, matter a lot more, especially as we start to see a lot more happening on the edge. So we talk about fog computing and sort of at the edge, what analytics are being done there, and also the type of information that's being sent to up to the cloud. Okay, so that's on the OPC UA side. Now, when we talk about classic OPC, again, it was earlier version. You get your name, and typically there's no relationship between different items in a classic OPC server. Not typically. There isn't any relationship between them. The way you imply a relationship is by using a dot naming convention where you would identify a particular asset, dots, and then you would add whatever the actual parameters that you're looking at. And visually, as a person looking at it, you would say, okay, well, these are related because they share the top-level name and then dot, and then you're looking deeper into the parameters. Of course, that is very error-prone. It's easily outdated as you start changing things on the systems, and consistency is quite hard to enforce. Whereas in OPC UA, this becomes part of the actual information model, and as you're commissioning these devices, or when you get a piece of equipment that's actually natively supporting OPC UA, it's not some kind of external OPC server that connects to it and tries to expose the data. That OPC UA server actually runs on the device, so the vendor can model and identify the best way to represent that information from the device directly on it. So when other UA authorized clients connect to it, they now have full access to the rich data set and the structure behind that data set without having to do any configuration, because that's actually built into the device. So of course that will, your mileage will vary. If you're talking about generic POC type applications, well, you can still set up models within that, but of course the POC vendor won't be able to give you a model because they don't know what you're going to use it for, unless it's a specialized POC. But still, you either have the flexibility to set up that model, or if it's a purpose-made device, then it can already have all that set up in it. So huge difference between OPC UA and classic OPC there. All right, so that's some of the functional stuff. And guys, there's so much that could be talked about here that, just for the sake of time, I had to be rather judicious of what I'm going to talk about. So pardon if it's not going into, into the, deep dive into each of those, because there's so much that could be said. But at least this covers sort of the high level view. So security, hot button, major issue for, all these systems. Basically, people, even if you see what's happening with social media these days, people are slowly starting to kind of look and say, well, just because you can doesn't mean maybe you should. And if you really should, then maybe you really need to control, who has access to what and how that's supposed to work. So security, whether it's from, attacks or even just how the data is handled and who gets access to it. So the access rights versus just the overall system security is huge. So in IoT systems in general, there's a talk of trustworthiness, right? So trustworthiness has various components that come together in order to make a system trustworthy. So whether it's available, whether it's resilient to attacks, whether it maintains your data confidentiality, the data integrity to make sure that the data is not getting changed, all those things come together, and overall, that's how you would start to evaluate trustworthiness. And this is something that the IIC that's how they put that together or packaged it, and then they quite often talk about trust. Again, this is input coming from various experts in many fields who contribute into it, and I think it's just good to talk about it here as well. And obviously, they saw that this OPC UA supports that as well. So whether you're talking about enhancing trustworthiness or you take more of an IT perspective of defense in depth, that basically this is a component within the overall IT infrastructure and it has its own mechanisms for protecting data, whether it's in the context of OPC or whether it's just acting as an IT component in the overall IT infrastructure. OPC UA has quite a few features, which I will briefly cover, that contribute to that. Okay, now one key thing is, traditionally we've often heard that, there's a lot of friction between IT and OT, because they have different, they're trying to get to the same place, but they have different priorities of what needs to get done, right? So traditionally, if we look at the OT side, the operations, basically, ensuring that systems are utilized, that they're running efficiently, that there's consistency, obviously, and continuity, keeping systems safe. Those are the hot buttons for OT. Whereas for IT, you take a look and it's, keep the system secure, try to reduce the costs, try to help set the system up so that you can drive better business insight, because a lot of times that's, of course, coming from the corporate side, and just overall flexibility of running the fleet. So when you take an OPC UA-enabled component, what happens is the standard was designed from the ground up in order to sort of facilitate the ability to do both of these. So when you bring that together, when you're trying to work with the connectivity, the way the data and services are provided, how you do optimization or how you're gathering intelligence, all of those, the things that you want to focus on, which is what IIoT is about, the arrow going up in the middle, you have to have a technology that actually doesn't just tolerate the requirements of some of these groups. It actually has to fully embrace them and incorporate them into it. And this is what the OPC UA standard does. So we're to look at some OPC classic threat vectors of what are some of the things that cause grief for different groups. If you talk about the IT perspective, if we look at DCOM, there's all sorts of issues with DCOM, right? So you've got intrusion and propagation of that intrusion into the system, potential system control takeovers because DCOM is plugged right into the operating system. Obviously, espionage and sabotage if you start to actually change things on the systems. And there's also network issues, ability to take a look at the clear text being sent within the DCOM packets because they're not encrypted. So again, that opens things up for espionage and sabotage. OT perspective, same thing, same technology, different issues. So looking at just how the servers behave, just the ability of people to come in and start to browse through tags or reads or do writes, if that's not properly controlled, then again, people can wreak havoc on the system. So there was quite a bit that happened there. Now, one of the things that was quite interesting to see is that when we're talking about Industry 4.0, since it's a German government initiative to make, to try to make their economy more competitive or stay competitive in the manufacturing field, as the rest of the world starts to automate as well, they of course ran heavy testing against various standards, and not just the paper standard, but actually implementations to see does this actually hold water. So what they did is they ran tests against these types of attacks, which are very common, right? So whether you're eavesdropping, message spoofing, change messages, replay messages. So they made basically a matrix to say, okay, well, let's take a look at the key factors that are involved in trustworthiness, so authentication, authorization, confidentiality, things that run along the top there, being able to audit what happened for detection and availability. So they made a matrix and said, okay, well, let's run tests on this. Different types of attacks will attack different aspects of trustworthiness. So this shows you sort of a quick kind of view of what each one did. And basically when they ran the test, OPC UA was the only one that actually came through and passed. Various standards have different capabilities, but when you look overall at what is the security that's implemented, plus what is the functionality, as I was talking about information modeling and how you actually transfer the data across and the efficiency and such, when you bring all those together, they basically came to the conclusion that OPC UA is what they have to base Industry 4.0 on, and that's what they did. So there are some security recommendations for how to work with OPC UA or how to set it up. The OPC Foundation recently actually came up with a brochure that does that. It gives some recommendations. I grabbed just one of the tables out of that. You can grab their, that's publication right off the OPC Foundation website. But basically, again, it goes through and identifies what are some of the things that OPC UA does that's just built into the spec that's expected from an OPC UA server to ensure that the things are kept secure, that the system stays trustworthy. So whether it's how efficiently the server discards packets that are malformed, so it's not trying to decrypt packets that are bad, purposely, for example, malformed in a form of denial of service attack, or how you sign or encrypt messages, depending again on what sort of what level of security you're trying to implement. All of that is actually thought through and built into the standard. So it's not something that could be bolted onto the standard so that you take a few standards together and say, here, see, we're just as secure. This is all built from ground up into the standard, and that's how come it just fits so well into the whole sort of dialogue on Industry 4.0 and IIoT. Okay, so in a sort of in a nutshell, I guess you can say that OPC UA is IT friendly. It passed extensive testing through the German government. They're sort of the equivalent of the NSA and the US. It's definitely firewall friendly, so the technology is designed for moving data across. It's not tied into any operating system. So basically what you're getting through is purely OPC UA data. It signs and encrypts, of course, the information, and that's important in how it does it. And the key word here is, or phrase is end-to-end, which means that even if you're going over transports, like let's say MQTT, definitely a very popular way of sending pub/sub information. But one of the sort of issues there is if you're going to go across, using brokers to move information as sort of jump points as the information is propagated from the publisher to the subscriber. One of the keys that you run into is if one of them is a bad actor, well, now since each broker decrypts the data as it goes and then encrypts it again before it sends it off, obviously if one of them is compromised, you just lost your security. OPC UA does end-to-end encryption, which means the publisher has its own encryption that it does, and once it's sent over, say something like MQTT, even if one of the brokers decrypts that information, it's of no value because the encryption actually happens and the keys are shared between or made available between the publisher and the subscriber end to end. And therefore, everyone in between is left in the dark, as they should be. They're getting in there. So we talk about security for data. We talk about data at rest, in process, or in motion. So those are sort of the three states that data has. And OPC UA is primarily and specifically focused on data in motion. So how do you protect the data in motion, but also how do you start that conversation? That's what it's focused on. Okay, so with OPC UA, you're minimizing your risks and while you're facilitating the connectivity. All right, moving along. So next one is usability. And we talked about the information models, and sometimes people are curious, well, so what? So I have an information model, what does that mean? And basically what that says is that if you're able to model different devices, whether it's a robot arm or any other type of equipment that you're trying to bring together, and let's say you have a number of these units, when you're commissioning a new one, if you expose the same model, then regardless of what the internal variables and states are for that piece of equipment, because it's, let's say, abstracting it through the information model that's being expressed, everybody actually talks the same way. So when you bring a new device in, you're exposing commands and the data basically in a consistent way as services and a consistent information model, which, of course, internally maps to however vendors are setting up their systems. But the ease of integration comes from, the more common your sort of interfaces are, then the easier it is to integrate them. Okay, so that's the sort of the advantage there. Deeper visibility. So again, when you start taking data from various sensors, for example, we talk about sensor to cloud. Well, in order to do that, typically the process control networks that have been around for the last, let's say, 20 years, they may not be able to handle the capacity of all the extra data that's suddenly going to start showing up if everybody starts networking their sensors and getting all sorts of diagnostics being sent out. Using OPC UA, if, for example, you're using pub/sub, it's very easy to have devices which could use a separate network. So whether, here I just showed a Wi-Fi symbol, Wi-Fi is quite popular or growing in popularity. Maybe some of the things are not involved in direct process control, but they're more diagnostics and for maintenance. They can be sent directly to cloud or to gateways and such, and then off to cloud for analytics. But basically, you have a much richer experience on what, or view into what's happening on your shop floors because you have extra data that can come out. It can securely be sent into an area where it can be analyzed. Conclusions can be drawn, and of course, you improve your uptime and your maintenance becomes more effective, etc. So by having these extra options, OPC UA opens the doors for really engaging all the valuable information that your systems have and drawing new insights from them and using them in new ways. Okay, so if we talk about integration, if we're trying to integrate systems together, typically you would need programming. So on the left side, I'm showing the integration. If you bring in new systems, and again, they have their own ways of expressing the data on them and then their configurations, then of course your programming has to account for that. And there's a lot of configuration that's done on the controllers in order to try to actually make everything work with everything else or to coordinate into a common system. What happens is when you start using OPC UA, because it exposes commands as well as data and information models, you have now services that are exposed. So increasingly, what you'll find is that components, when they require a certain type of service and they are on the same network or they're working together, they can actually communicate amongst each other. And this is where we start to see that autonomy show up. And if any of you ever travel to Hanover Fair when they're doing the Industry 4.0 and they give the huge SAP example of how systems are communicating together or they're moving around production cells and such, that's actually what's happening, is that these systems, because they publish their own services and other systems need some of those services, they can actually start coordinating amongst each other. But you still need to have, obviously, something that coordinates overall the process, but there are these signs of autonomy that start to show up. Okay, so that is a whirlwind introduction to all the different things that are happening or why OPC UA is significant and how it differs from OPC Classic. So now I'm going to hand this over to the presentation to Stan, who will start to talk to you guys about some of the things that you can do today. And yeah, you can take it from there. So Stan, take it away.
Thank you, Derek. Can you hear me okay? Am I coming across?
Yep, can hear you fine.
Okay, good. Thank you. Yeah, that was a lot. If you feel like you were drinking from a fire hose, you probably were. So I think Derek did an excellent job of explaining where OPC UA is as a technology, its capabilities, and why it's a great technology to adopt. We talk about IoT along with OPC UA, and I think most of you probably understand IoT is a much broader industry term about smart devices, and we all know about smartphones, and now the idea is to make all equipment smart as well. But OPC UA is an enabler, and it's a big enabler for IoT. So that's giving some perspective. And classic OPC UA is the one that's been around for years, and not to diminish its value, because I've been around for years, 20-some in this industry, and OPC was it for many years as the connectivity to the equipment, and it still is widely used and largely in most automation plants. So with that said, there is a need to move from classic OPC to OPC UA and better IoT enablement through the new OPC UA. What's shown here is some of the challenges that manufacturers, oil companies, energy companies face when considering moving to a new technology like OPC UA. They can't just rip everything out. It's just cost prohibitive. There's no way to do that. I mean, I worked for a software company many years, and one of our biggest ball and chains was always legacy. We all deal with legacy, so you can't just forget about legacy. You have to bring it along with you. And I'm going to talk about that, how you can migrate a brownfield plant, which most of the plants are, and how you can take an existing OPC Classic enabled plant and how you can migrate it to OPC, and some of the reasons, and how you would go about doing that. So all these things listed here, multi-vendor, third-party components, legacy data connectors, a lot of OPC Classic out there, as I mentioned. OPC UA, rip and replace legacy systems is just not an option. This is actually a major initiative by an organization called the Open Process Automation, led by ExxonMobil, to address this very challenge of moving companies or adopting a standard, and OPC UA being a big part of that allows this interchangeability. So the OPC UA migration, there's tools. Matricon provides a tool called a tunneler, a server that can be used as on the client and the server side. So on the left side, you have a classic client that you want to connect to OPC UA servers. As you start introducing the OPC UA servers in your plant, you can use the tunneler enables you to continue to use your client. Here it's shown as a historian, could be a SCADA product that you want to connect up to this new OPC UA server that you now have, and the tunneler allows you to do that. And vice versa, if you're starting to implement OPC UA servers in your, or you introduce now an OPC UA client, there's more and more of those out there, SCADA type applications. You can connect them to OPC Classic using, again, this tunneler technology. And in addition to allowing the interoperability between OPC UA and OPC Classic, the tunneler also is firewall friendly, so it also can give you that ability to pass through your firewalls and the security needed to go outside the four walls of the factory. So this is a major part of a migration strategy as you move your plant, your operations from Classic to the new OPC UA technology. A case study, oil refinery, or actually an energy company, they had a goal of reducing the cost of data connectivity and communicate using their existing infrastructure. But they were hamstrung by OPC Classic and the requirement for Microsoft Windows, and also they needed better security and resilience. So they used the tunneler, and looking at their initial architecture, very simplified, of course, but going from a DCS through OPC Classic, using the tunneling software up through a firewall and out to a OPC Classic client. A lot of software equipment along the way to get from point A to point B. In the new architecture, you can see pieces are removed. OPC UA can go directly through the firewall to an OPC UA client on the other side in the cloud, in a data center, wherever it sits. And you don't need the tunneler in between, so you remove that software. You also remove the extra needed servers, and it's platform neutral or independent. So whether you want to run that across Windows or Linux or Mac OS, whatever operating system you want is available to you. So now this is a very simplified view of a before architecture with OPC Classic versus with OPC UA. But in reality, and if I don't have a slide on it, but there's a much bigger picture. OPC UA offers a much an opportunity for a much different architecture and a way to reduce infrastructure costs, the ability to go to the cloud securely using OPC UA, and things like Azure and Amazon Web Services support OPC UA natively. They have their own OPC UA gateway that'll connect locally at the plant and up through their cloud infrastructure. So you can, with OPC UA, it's again an enabler, allows you to come to define a very different infrastructure, reducing those costs of all those expensive servers and maintenance that many end users have sitting in their factories. I'm going to move pretty quick because I don't have very much time, and I want to leave a few minutes for questions. And you can ask questions as we go here if you have any, and we can answer those as we go along. So just another view here. at the bottom are various devices. On the left is, some kind of software that's interfacing by OPC Classic. Of course, we have the tunneler that was spoken about previously that'll give you access to an OPC UA client. We have proprietary protocols. We have all the different industrial protocols, and there's now many devices available, as shown on top of these proprietary and industry protocols that convert through gateway technology to OPC UA. So there's many devices available to make that translation to convert to OPC UA. And of course, there's the ability to develop a OPC UA server. In the case of the proof of concept there, the DART device that maybe doesn't even have a sensor on it, you can create a small sensor. You can put OPC UA directly on it, and you can create a simple OPC UA server and give visibility to that device. Kind of in the future, and it's starting to happen today, but it's something that is evolving, is equipment manufacturers putting OPC UA directly on their devices. And I can tell you it's happening because we are being asked to do it for vendors, and that's one of our key targets for our business or markets, is helping vendors, equipment manufacturers, put OPC UA on their devices. And they're coming to us telling us that their customers are starting to ask for it. So that's a good indication that the adoption is really going up. So OPC UA is a rather large standard, and there's a lot to it and a lot to consider. And we, as Beyond, have developed a 5-step process that I'll walk you through quickly. It's a way to plan and implement and deploy and roll out OPC UA in your plant. And it's not something that happens in weeks or months. It's something that happens in years when you talk about a complete rollout and a complete migration from a more, say, traditional architecture to an IIoT architecture. So first thing is we really encourage end users to involve their vendors along the way, their strategic vendors. I mean, to understand what they currently offer in OPC UA and educate them on what their needs are as a manufacturing operation and their automation needs, and to influence those vendors to adopt OPC UA and various OPC UA standards to meet their needs. So we think it's important that they be involved along in the process. The first step is strategy, and when I talk about years of time frame, I'm really talking about the rollout when you get down to step 4 and 5. So the first steps are typically shorter. We're talking weeks type of thing. First defining the strategy, which is a lot about goals, setting goals, prioritizing goals in terms of IIoT, where you want to go, what things you want to enable with IIoT. I call it a functional map, basically kind of like a blueprint of your application space that you want to implement throughout your operations. Basically, just look at a high level where you are today and where you want to go, and from that, define an initial IIoT strategy based on OPC UA technology. With the strategy created, then the next step is to develop a roadmap, which is the long-term plan, and defining what the future architecture will look like, long-term, kind of the end goal. And then with that, what are the steps to get there? Kind of a roadmap, and that's the roadmap, the plan, how we get from where we are today to a fully enabled IIoT business. And that outcome is a roadmap. And part of that typically is proof of concepts. Normally, that's a normal step to prove out concepts that are defined during the road mapping phase and build the business case. Training, it is a new technology to many companies, so there's usually some training involved, and we offer 2 types of training, one targeting directly developers the other targeting IT professionals and more on the infrastructure architecture side. And usually, along with the training, there's a period of consulting that is often desired, required to really work with the teams to move forward. And that's not only with the end user, but of course, again, vendors being involved, that can also entail training and consulting with vendors. And then the pilots. So this is all about implementing a proof of concept, putting a small plan into place, trying to create something at a minimal investment that proves out the things you define in your strategy and your roadmap. And from that, you'll come with you'll understand better what the value is. The business case will be better formed, as well as which will help with the funding when it's time to go after funding, because the next step after the pilots is where the real investment comes, when you are planning to roll out full solutions across potentially many sites. So that's where really it's the last step where the years of time come into play. You don't re-architect your whole automation network in a few months. So that part takes time. But the key is, again, it's not just literally through this process. It's going back and changing your plan and adjusting your plan as you go. And I know I'm past the 2 hours, past the hour. I'm just going to go very quickly through the vendor, and I only have a few slides, so I'll keep this very short, and I do apologize for this going long. I'll stick around and try to answer questions if people want to stay on the line. So for the vendors, we also work with vendors, and actually we work a lot with vendors right now, because it's something that where OPC UA is today, there's a lot of work to be done to get the vendors completely onto OPC UA. And so we work a lot with vendors, and but OPC UA is a rather large specification, as it says, comprehensive. As Derek pointed out, it's very scalable, very flexible, and with that kind of standard, usually it comes with some complexity and some size. So what's shown here is there's 14 parts to the OPC UA specification. So it can be rather daunting to somebody just coming into it cold. There's 377 conformance units. As shown here, these are just the groupings of them. There's different number of and conformance units are different types of requirements, options. I mean, there's security, for instance, that has many different conformance options. But there's 377 options and parts to OPC UA and things to consider. And that's our value add, if you will, in our expertise and our consulting, is to help vendors find their way through that and determine exactly what pieces they need, and help them focus on the parts of OPC UA that are right for their product, and put together a phased approach. You don't need to bite it off all in one chunk. You can do it in steps. But in most cases, you also don't need all 377 conformance units. You need some subset, and with our experience around OPC UA, we can cut to the chase pretty quickly. Certainly a part of it is a tool set. SDK is going to be required. Matricon has a very attractive SDK. It is very performance. It's very high performing. Also runs on any scale, embedded on very small devices. It can run bare metal, so it doesn't even require an OS. And as mentioned before, they have the tunneler. So even as a vendor, you might require the tunneler until you have OPC UA implemented, so you can talk to clients, or when you do have OPC UA implemented, so you can support backward compatibility to OPC Classic. So the tunneler gives you that interoperability for your product, as pointed out earlier. And just real quickly, this looks very similar on the surface, but it's quite different in the details. This is a 5-step process again, and its first 2 steps are assessment and roadmap, but now instead of looking at a factory automation architecture and multiple site rollouts, this is looking at a product or a product line, and it's looking more into the details of all those conformance units of OPC UA and how they apply to a given product. So it is a 5-step process, but it's a very different type of process when you get into the specifics of it. We start with an assessment, which is introducing OPC UA to the leadership team of a product company. That can be product marketing and development leadership, reviewing their current vendor technologies, and then how OPC UA can be applied to meet their goals. And again, so we work with the vendor to understand their customer requirements, their desires for their product going forward, and then map OPC UA into those requirements and help them identify a plan on how to meet those requirements. And it all comes down to, in the roadmap, working out a backlog. So we get to the point of developing a phased approach, typically, of an OPC UA adoption, and develop a backlog with various sprints to get from one phase to the next and to the ultimate goal. Similarly, as with the end user adoption process, we offer training. Here it would be more focused on developer training, and we do ongoing consulting, as well as doing the actual development. We do that either fully outsourced or in collaboration with vendors to implement OPC UA in their products and prepare a certifiable product. And last but not least, we will help get the product certified, get it through the certification process so that the vendor comes out with a fully OPC UA certified product. So that's very quickly, and the goal of this process is to help implement OPC UA as quickly and as low cost as possible in those products. And I apologize again, we did go long. I see some questions have been coming in and being answered. We're about 7 minutes over. It's now fully open for Q&A. The slide here is just showing what the next steps might be for you if you're an end user or a vendor. And there's some links for accessing some software and some services. So sorry for the fast pace and running over. I apologize. There was a little more content, I think, than we could fit in 1 hour for this webinar. Derek, it looks like most of the questions have been answered.
Yeah, so we've had a few. There are some interesting questions, and again, we will be getting back to people. If you have some outstanding questions. There was one in particular interesting. Somebody was asking about buffering. How does OPC UA handle buffering? I'm assuming it's with reference to if you use connectivity or reliability type uses. And maybe just I'll quickly grab that one. So OPC UA has various mechanisms for making the system more reliable. Now, buffering, of course, is a very broad term. It depends how you want to use that data. So if you're using a real-time stream and you lose your connection, OPC UA allows you, for example, gives the possibility to actually request DA values that you missed. So basically, when the next packet comes in, it'll give you some of the past values that you missed when you, for some reason, lost your connection and you came back. That is a very short, that's not meant as a historical request. So you're going back and actually fetching information from the buffer, but it does provide the ability to recover the data that you may have lost. Other types of buffering would be actually just, since it mixes in the DA and the HA, the historical side of things, if your product actually has history attached to it or another component does, then of course you could just request historical data. Again, you could have a whole presentation on that. So there will be, there's a lot that could be answered, but guys, absolutely, if you just saw the presentation now, please, before you take off, send us the questions that are coming top of mind. We'll be very happy to follow up and answer them, Stan and I, after the thing. It's fresh in your mind now, so if you got a question, get it in there. But I think we're going to have to shut it down because we're already keeping people over by 10 minutes. Stan, good job getting through that. That was a lot to get through in the time that you had. So it was.
Yeah, no problem.
All right.
Yeah,
so
thanks everyone for joining.
Yeah. And guys, just one final thing. We do have some polls. We will be in the information that we're going to be sending out after the webcast. We continue to generate more collateral after this. But since we have so many people who have signed up and participated, we have some questions for you as far as, some of your decisions and some of the things that you're doing with OPC or considering, and even ideas about future webcasts. Please take a moment and fill that in. We will aggregate it and sort of send out information together with other materials so that you get a kind of a feeling of what your peers are doing as well. So that's one of the advantages of having so many people come in and join us. So, okay, if you can, please do that. Otherwise, again, hope you found it useful, and enjoy the rest of your day.